Илия, нещо не се разбирам на английски, ще си говорим на български.
No worries.
Да оставим някакъв запис в историята, че се е случило събитието.
Да, само камерата да е към тебе, наобратно, защото се че не с мен.
Даже
Не вярвам да сме единствените, които се оправят събития с един човек.
Що един на 4 маса?
И това го имам.
добре.
Аз някои неща не ги знам, така че съм моля, че ще ме почнеш.
Hello guys, yeah, to the third blockchain kind of developers meetup board for Polkadot related. Today we're going to talk about Parachains, smart contracts, the whole ecosystem around Polkadot, how it relates between the other chains, how it can deliver this promise of interoperability between the chains, and how the whole, what are the benefits, what are the pros and cons of using parachains instead of smart contracts, and how our, let's say, decentralized application can live in the whole Polkadot ecosystem. So, yeah, parachains and smart contracts. We'll cover these main four things in this talk. Smart contracts, the typical ones that we are used to see in Ethereum and other blockchains. Parachains on Polkadot. Substrate, which is the Polkadot's framework for building custom independent blockchains or modules or parachains that integrate with Polkadot ecosystem. And blockchain updates, that is the term in Polkadot, meaning which is similar like forking in the typical blockchain networks that we are used to see. And if we have some time in the end, I'm gonna show you some demo of building a custom substrate module that Gavin Wood showed us in Berlin on the Web3 Summit, which is a simple game of just putting some dots or units in a pot, and if you're lucky, you can get all the pot, the whole prize reward, and that's it. Just a gambling game. So first, smart contracts. The first thing we, think about when we see smart contract, or if we think about building a decentralized application, the first thing that pops out in our minds is Ethereum, for example, or some other simpler blockchain that's easy to develop on. But smart contracts are some kind of limited. Limited in terms of complexity of the state functions that we can basically define with the smart contract. It also has some pros and other features that are unique for the whole thing. For example, we have very good and fantastic, let's say, permissionless model or permissioned or whatever we can think about. We can make also we can be sure that the smart contract or our decentralized application it's running forever, and it basically can assure us that our code is doing whatever it's supposed to do and whatever it's written on it, if it's audited correctly. Yeah, and most people when hearing about smart contracts, they think about the EVM, because it's Ethereum is the most widely used for nowadays blockchain for develop. But we have some limitations when we are using smart contracts. For example, we have this idea of gas, which is the unit that is metering our operations done in the smart contract. So our smart contract is kind of metered state transition functions. Our functions that we execute are metered. But we have also some pros. Let's say we can easily call one contract from another, and from the other contract you can call the third one. And this is something built in from the blockchain network, which is something cool, but it is synchronous. So we can basically do this in one VM instance. When we hear about smart contracts, I said Ethereum, but there are lots of other blockchain platforms that allow us to develop decentralized applications or do some business logic or build some, some more conditional, like state functional logic on the blockchain. We can develop a smart contract on RSK, which is the Bitcoin version. We can develop on Ethereum, as I said, Eternity, Stellar, Waves, and lots of other platforms. But there is this problem that you're basically bound to whatever blockchain you decide to put your decentralized application on. So this is a thing you have to consider deeply before starting developing, because it basically defines the future of your decentralized application, at least nowadays. Actually, there is another benefit of using smart contracts, which is they're easily deployable, so everyone can easily deploy them, and basically the border of entrance is pretty low, and it's not that complex to create smart contract or decentralized applications. Yeah. Parachains. This is the term of which Polkadot created, and they introduced us some new terms in the whole ecosystem. But Parachain is this green thing here. We have, let me try, yeah. So this green thing here is the parachain. This is the whole relay chain, if you remember from the previous meetups that we talked about parachains and the whole Polkadot structure. It's basically, we have a relay chain, which is the main chain, which is handling the whole security layer and the basic layers of the blockchain. We have here some validators that are randomly chosen every day that basically serves us to provide us security for our network. We have here a bridge. I'm going to explain in a brief. And for now, we're going to focus more on this parachain here. So when we decide to create a parachain, basically the parachain is a WASM block. So it can be written in different languages like Rust, C++, Go, or I believe these three for now. But it's basically compiled to WebAssembly at the end. And our parachain becomes a block that it's signed in transaction and passed through the relay chain. So when we create a parachain and send it into a signed transaction, the validators in the relay chain, they decide, they have a governance model that decides whether our parachain is legit and whether it should exist on the Polkadot network because of the possibility of arbitrary parachains that are malicious and stuff like this. there is this mechanism of basically validating the parachain for its existence. The last time we talked about the collators, fishermen, and other players in the whole ecosystem. So when we create a parachain, we have collators here that are part of our parachain. They basically work as full nodes, and they provide the whole block history and the whole history of what happened and what defines the block in our parachain. Because I forgot to mention this one, but in our parachain we can define whatever we want as a logic. It's basically our own blockchain without worrying about security, which is provided by a relay chain. So if you decide to create a blockchain of your own, you will have to handle lots of things. Like, first, for example, you need to think about the consensus mechanism. Second, you need to think about the security, the whole players, the data structures, the transaction structures, and stuff like this, which are basically provided to us by the relay chain, and we can get them easily by using the substrate, which I'm going to talk about a bit later, and create ourselves a parachain, which is basically if it's easier to make the visualization, like a side chain of the Polkadot main chain. So there we define our logic and how everything we're going to work. The collators basically are storing all the data, and they are providing the data for what a block is looking like, and which is the valid or the next propagated block to the main relay chain. So every time this happens, we have random chosen stakeholders or validators on the relay chain, which are basically staking their nodes, and they are validating whether this block is valid or not based on what our collators and our logic here in the parachain is meant to be. So this is when we are using the Polkadot's built-in relay chain as our provider for security and validation of our blockchain. The collators here, as I said, they are kind of full nodes, and here our validators, they are basically kind of light nodes. They don't store any data for our blockchain, so they only rely on whatever the collators provide as data for validation. You can ask yourself, because this is kind of thing that can be gamed, like the collators can provide malicious data, or some of them can be cheating on the others. That's why there is this fishermen, which are basically watching for the collators if they're providing the correct data, and they get incentivized and rewarded if they catch someone to be cheating. And we have here, like,
do they do this by some, what is the logic they use?
it's based on the logic that you've created in your parachain, but it's something that is structured and built in Polkadot, so you can use them.
There is no consensus that they use to validate this stuff.
There is a built-in consensus in the relay chain, but you can change your consensus in your parachain. So based on your logic and your consensus mechanism, you can define whether how they should look for valid and malicious
What valid means.
players. Yeah. Basically, you are defining your valid, your block, or whatever, your host default structure. You can define it however you want. But via substrate, you can get this all built in, and you can use it however you want. You can use it like however it's built on the substrate, or you can modify it, or you can basically it's kind of modules. You can basically remove the consensus module and put whatever you want there with your logic or the account logic, for example. You can get it built in, but you can basically define yourself an account logic and use whatever you want as account logic. So yeah, in Polkadot we can have lots of parachains that are connected to the relay chain, and basically by connecting themselves to the relay chain, they can connect to each other. So if we have here like another parachain, it can connect through the relay chain and transfer messages. And the messages can be structurized whatever you are defining your logic in your blockchain. So however your message is defined, you can pass it through the relay chain via their protocol to another parachain.
Do they implement some interface or?
Yeah, there is this interface which is unnamed now, but yeah, it's basically message transition or message.
If the parachain on the top is A and the other one is B, if B wants to send a message, it needs to send the message specifically to A, right?
Yeah,
or
you can.
Can you just put a message on the bus, on the relay chain, and a specific parachain is going to pick it up?
The relay chain is not storing any data, so you need to define whoever you are sending it to.
Oh,
But you can, yeah, you can basically send it to anyone if you want.
yeah, but you have to know their address. Basically, and you have to speak the language.
Yeah, but yeah. The language is this protocol, so everything is structured. You can transfer it via this message protocol, so everyone will be able to read it.
Okay, so everybody speaks the same language, but you still need to know the recipient.
Yeah.
So the recipient is defined not by function, but by address. Basically.
Yeah. But yeah, if we had this case of sending message to everyone, it would be easier to flood the network. So
Sure.
probably it's some sort of spam prevention of I don't know, giving you the opportunity only to send to wherever you know to particular address.
Okay.
So this is the purpose of. Let me see if I.
The parachain.
Yeah. Okay. So another thing that is maybe the most interesting and the most important is that you don't have a metered state transition here. So you don't have anything like gas in Ethereum, for example. You can basically build as much complex logic as you want, and it's not metered. You don't pay for the execution. You can rely on it to be executed to the end and not get out of gas error. Another thing is, yeah, you're basically trusting the validator set here that is chosen by the relay chain on random algorithm. So there is almost no chance of someone intervening your
Yeah, I think there's no way to
validating work. Yeah.
Can you abuse the relay chain by creating too many parachains?
I don't think so, because as I said in the beginning, the relay chain has some sort of governance mechanism to basically allow whatever parachain is deployed on. So if you're deploying if you're deploying many parachains that they will at some point know that this is a malicious purpose,
Just move
and
the
they can
information.
just drop them.
Okay. Alright, so you can, if they don't catch you, but they'll probably
Yeah.
don't catch you.
They probably will. The parachain bridge is a parachain that is communicating with some particular blockchain. We can basically create this bridge, which is using this messaging protocol here and translating the whole messaging, the whole protocol for the messaging and the transactions of the, for example, Ethereum here. So basically, by creating this kind of bridge, we can interact between our parachain or other parachains and the network itself. And by creating, for example, a bridge to Ethereum and bridge to Bitcoin and bridge to Eternity and bridge to whatever, by using the relay chain and other parachains and substrate modules that are created as parachains or as separate modules, you can basically use data from all the other blockchains. And for example, this is a good use case for decentralized applications like decentralized exchange. They can basically share their order books or make easier atomic swaps or like, yeah, these kind of things can be done easily via using this, the whole ecosystem. It can be like a bridge between anything.
So basically you can create your own contract, smart contract using functionalities of many chains by creating a parachain, which is going to
Yeah, and your parachain.
orchestrate the...
Yeah. And you have some more complex logic. You can create a parachain that executes that, and your basic logic can lie on Ethereum, for example, or other blockchain that's mainstream, that's easier to use from the users. But you don't pay for the whole calculations and the whole state transitioning. So you can create, for example, Evo, he's not here today, but they've created this protocol ADEX Outspace, which is basically a protocol for handling payments, payment channels. So they created a parachain for this, and basically can serve you for the whole business logic without paying any gas.
Why are you not paying?
There is no payment here
But
in the parachains.
where is the parachain executed?
It's executed on the Polkadot network, so it lives in the runtime. As I said, it's created as a WASM blob, and this WASM blob is basically put into the runtime of the relay chain, and it's executed when called there. It's asynchronous, so when it's only executed when it's called.
So basically it's somebody's computational resources in the end.
Yeah, it's in the end this. There are lots of nodes that are validators. They're providing also resources and they're supporting the network, but there is it's basically a proof of stake network, so there is no money, there is no incentivized people to support and have like large mining farms and stuff like this. Yeah, as I said, the messaging is also asynchronous. I forgot if I mentioned it.
So actually the relay chain removed the possibility of you spamming the network, as we said earlier. This
Yeah.
is what helps you to have no fees. Because
Yeah.
otherwise, we've seen recently projects like Tezos, Eternity, everybody said, okay guys, we're gonna be free, and then we just now have to add fees because otherwise we get
Yeah.
spammed.
You can
Yeah.
define in your parachain to have some sort of a fee. You can define your parachain to have some unit, but this only depends on your use case. You can do it without it.
Yeah, no, it's from Polkadot's perspective. There is no charge.
sum up. Something I forgot. I told you about the substrate, which is a framework for developing on Polkadot. It basically gives you the whole basic stuff for a whole blockchain, like account logic, hashing algorithms, block structures, consensus, DFTs, and stuff like this. And you can use it, just get it from GitHub and use it. And when you you can basically define some new things and replace the other things, and it will work easily. And that's the way for developing parachains or independent blockchains that are not connected to the relay chain. I mentioned about them some meetups before, and I will briefly mention them again. But yeah, so if you don't want to use the relay chain as your validator and as your security provider, you can define your own security here in your parachain, and it becomes an independent blockchain. So you don't rely on the relay chain for the whole consensus and stuff like this. But you can also use the whole pros that it's providing for you, like the messaging and whatever you decide to use.
Okay, so it's on demand.
Yeah. So Substrate gives you easier way for developing modules, parachains, and independent blockchains. It's a very cool framework developed in Rust by Verity, and I'll show you a bit later how we can create some sort of parachain. Okay, so to sum up, smart contracts, they're usually written in Solidity, Viper, Sofia, Microsum, or whatever other language, depending on the blockchain that you're using. They're metered, meaning that you have this, your calculations of your state transitioning functions are metered, and you pay for them with gas, whatever it's defined in the blockchain. They can call each other synchronously. As I said, one contract can call another. They're deployable by anyone, and they can be deployed without any permissions. You can basically write smart contract and deploy it. They're promised to run forever, but forever is an abstract thing, depending how long the network will live. Because if the network shuts down, your contract is gone. And they are relying on for the security by the network that is provided for them. Parachains, as I said, they're written usually in Rust, C, or Go, and they're compiled to WebAssembly block. They can call one another asynchronously. They are unmetered, so every state transition is basically free. We don't have here a term of gas. As I said, to deploy a parachain on Polkadot, we rely on some governance from the Polkadot stakeholders that are basically checking your parachain and sort of saying whether it's not malicious or what the purpose is. So they're validating whether it should exist or not. And the security layer can be provided from Polkadot, but you can rely on your security as I said. So, yeah.
Are they gonna live forever? Or run forever?
I believe it's the same as the other networks. So, when developing, you can, I don't know, you should think again deeper and think for yourself. But if you are relying on, let's say, Polkadot or whatever other blockchain, or when you're developing decentralized app, it's a nice thing to at least support the network with a full node or at least a light node or something like this. And this way you're sure that the
Your
network
information
will
with you.
survive. Yeah, your information is still there.
Yeah.
So it's the same with Polkadot. It's easy to run a node. It doesn't require much resources. You can basically fire up some VPS on Amazon or DigitalOcean or whatever and put it up running, and that's it. You forget about it. Okay, so this was the presentation. Now I'm gonna try to. Okay. So as I said, the thing that I'm gonna show you was shown by Gavin Wood himself on the Web3 Summit in Berlin last year. And we will create this simple parachain that introduces a game. So there are some things that we need to have installed before starting developing on Substrate. We need to have Node and NPM installed. I already have them, so I won't show you how to install Node and NPM.
Yeah, we're gonna need the breakfast.
Another thing that we need to have before starting to be able to run Substrate is installing Rust and its dependencies, Rust lang. And the guys from Polkadot have created, let me just increase here the font, have created cool one-line installer that we can use. I already have installed it, but for the recording, I don't know if it's gonna be visible there, yeah, but so that's the command line. Basically, they created a bash script on this web, which is basically pulling and installing every dependency that you need for running Substrate. And another two things that we need to have are these two, open them, these two repos that are basically boilerplates for,
It's not on the screen, right?
yep. This is the one, the Substrate template node. This is a template for a node for a blockchain network. And another thing is the UI for interacting with our, here it is, for interacting with our node and our blockchain network. So let us start it. We can clone the repos, or basically after installing this script that I showed you, you're provided with two script aliases that you can use. So we're gonna be using them. Let us make so we are starting by Substrate node new, and we are giving here the name of our node. So it will be substrate game node. And the outer, which is okay. I work here, but let's hope it will be downloading fast. While we wait, we can initialize our UI by the next command, which is substrate UI, and again the name of our UI module. Okay, substrate UI. So this is creating a UI interface for our network. It's pretty slow here. Here it's already built, but I suppose we should wait a bit, and if it doesn't load up, I'm gonna walk you through the code that's already running.
Yeah, I think it's also okay to show how you get there, but if you haven't already, you can. Because
Yeah, we'll be
here
waiting
you
a
don't
bit.
see any signs of life.
Okay.
No. Wait a second.
Okay. There is a sign of life.
Unexpectedly.
So it's loading all the dependencies and all the binaries for building the WebAssembly runtime and everything I showed you in the repo. Basically, it's pulls it and installs the dependencies. We're almost done with the UI. Okay, so let me open up, at least show you the UI because
This thing is done.
okay. Okay, so now we have the UI installed, and if we run npm run net, it should run. Okay. I'm not in the correct directory. Substrate game UI. If we run it, it will fire up a node server, and we can see it on the local host. Just wait a bit, local host on port 8000. Here it is, but I suppose it won't be showing. Yeah. Okay. So we have a basic UI with wallet logic, address book, and a way to send funds from one address to another. Here we can upgrade the runtime, which is where we will put our logic for our blockchain, basically our parachain. This is the way to easily upload our WASM block and upload basically our logic to our parachain. So it's kind of forking the whole chain. Let me see what happened here. Almost.
we synchronizing with all nodes now?
Here we are synchronized. We are not synchronized, I believe, to anything yet.
No, the substrate, this is 87, all the nodes that are in the network, or why it's put into that?
Where you see this?
Down, under, the last line, not on the UI.
I believe it will be better if I the red one, the the one that I already built, because it will take a cost to type.
Let me just make it like this.
And basic. Okay. So this is what we get when we install our template for the node. We have a runtime folder, we have a source folder here, which is basically the logic from the substrate framework. We have the chain specifications, where we basically we have defined our testnet and our Genesis settings. We have here some, okay, this is the testnet config. This is the logic for the balances, the creation fee, transfer fee. If we want, we can, if we want to have fees in our network, we can change some numbers and we're good to go. Also, we have here the balances logic, the initial balances, and other things. This is the timestamp, which will be the period between the blocks. So here we have 5-second block time. We can make it however we want, as big as we want.
This means you can't change it without recompiling your parachain.
You can create it, you can change it, but if you change it, it will become a separate chain, separate blockchain, because it won't be the same as the parachain that is the main chain. So
Changing the logic.
yeah, you're changing basically the logic. And yeah, here we have some other stuff. Here is the CLI, basically using lots of libraries, and this is what we will be seeing on the runtime console. This is the error handling logic for the chaining, and the main file here. Here we have the name of the node and the network, the executable name, and descriptions and authors. Basically, system stuff. Not interesting. The interesting stuff is here in the runtime folder, where we have this source folder, and this demo is what I've created, but yeah, you can see it's in green. These two are the things that you get when you install it for the first time, and this lib.rs is our file where we are including our libraries and our modules that we create for substrate. So here again we have some system configuration stuff like logic for encoding, decoding, serializing, and deserializing. They are basically imported from the parity module, but you can use whatever module you want, and you can change whatever you want as you want. using a timestamp, balances, and other stuff that we need for our parachain to run. Here we have the whole key logic, which is ED25519 encryption. We can change it whatever you want with other library and other encryption method. And we can define it, I don't know if you're familiar with Rust, but basically here we are defining the type of this is basically a generic type that we are defining, our account ID, which will be a primitive from here with age 256, which is a hash of 256. Here we can define our hash, so what a hash will be in our parachain. We can change it according to our hashing algorithm and our logic. Here we have the block number, which will be an unsigned integer of 64 bytes. We can create it like, we can change it like this and make it 32. This will be how big the number of the block will be and what will be the block number structure.
So do you mean bits or bytes?
Byte. Here we have the nodes, and yeah, they're basically this is the whole stuff here is coming by default when you install it. The only thing that I have here added is here mod demo, which is basically importing the logic from my demo.rs file. Yeah, module. And another thing that here we have the consensus implementation. Basically, we're here initializing stuff as traits. In Rust, we have traits here that are stuff for the runtime. And yeah, we have here for our module, we don't have anything to put into the runtime yet. So that's what I defined here. So let's see the demo. We are importing here the parity codec again, and we have this support module, which is giving us these macros for declaring a module in the substrate, declaring the storage, so you can declare whatever we'll be storing, and declaration of event, and these two things for the storage value and the dispatching of the result. We are importing again the balances, and basically this will import our account logic and how to deal with wallet accounts and addresses. And we are importing here this function that will be checking whether some transaction is signed or not. We are importing here the runtime primitive of hashing, so basically our module understands what hash is. This is our, let's say, constructor. We don't have anything in it. And we are defining our module here. This is system stuff. So basically every module starts like this. And we are defining the functions in our module here. So here we have two functions. The first is play, and the second is set payment, which will be basically getting the handling the logic with the balances and stuff. The idea here, as I said, is you can put money or units in whatever is counted as money in our network, and you have a pseudo-random thing that I'll get to it, but basically if you win, you get the balance which is in the pot. So here we are basically checking whether which is the origin of the transaction with this ensure signed and origin. This is an option. It's this here is an option, so it's basically a Rust thing. It can return whether an OK or no. Yeah, it can. So basically, we are here checking whether the sender is a valid one. Here we have the payment logic. We are getting the value for the transaction and putting it in a variable that we will be using.
The previous one is like required.
It's similar. Yeah.
Make sure that he signed the transaction.
Yeah, if we have here, we can check the. Okay. Maybe it was a bit clearer when I just pointed at it. Here it says, ensure the origin represents a signed eccentric. So it can return OK or error. The error basically will abort the execution further. So if it returns OK, it means everything is OK with the transaction, and the sender account is saved here in this variable that we are using later. Same is for the payment, but here we are checking this with self.payment. So we are checking to whether there is a payment or not. This is a built-in thing in the declaration storage, which we'll see a bit later. And we are using this again built-in function OKR. So if it's OK, it continues the execution. If it returns some error, we are providing here an error message to the executor of the function. Here we're decreasing first the balances of the sender. So we're saying the balances in our module. We are using this built-in function for decreasing the balance. And we are saying to decrease the sender balance by the payment that he is providing. This is a pointer for the sender, because here in Rust, I don't know if you're familiar, but in Rust, there is this concept of ownership of the data. So if you pass here the sender without a pointer, basically it will automatically garbage collect everything after executing this, and then we will not have anything in the sender variable. So we're providing only the pointer to the sender. So first we are decreasing the balance, and then we have this check for the flipping, basically flipping the coin, or the check whether we are winning or not. We are using this built-in system module for getting a random seed, and we are checking with this function using encoded whether the hash. So first we are getting the hash of the seed, and then this is here some sort of like map in JS. In JavaScript we have a map. Basically it's filter. In JavaScript we have filter, where we can say something dot filter and provide some logic here. And we are expecting it to return a boolean whether it's true or false. So here we are checking whether the first byte of this hash is lower than 128, and this will be our winning logic. So if it's lower, we win. If it's not, we lose. And if it's lower, we are getting into the if body and increasing the free balance of the sender with the pot amount that our bot is collecting. This is again a built-in function take. It's take the whole value from the storage and then passes it wherever you set for it to pass. And at the end, as I said here, no matter the outcome, we add the original payment back into the pot. So we are increasing here the payment, and we are turning OK. This is something that is necessary because our function here is declared to return some result. For the second function for the payment logic, we have here this if statement, checking whether the payment is set or no, and we are putting basically the value in the pot here, and that's it. So we have only these two functions, and this is our storage declaration. Basically, we are saying here what we are storing as structures or whatever we are storing as data in our parachain, which is only the pot here and the payment, and this is a getter for the payment. Okay, and yeah, that's it. So in order for us to see it in action, we need to do a few things. First, let me just open again my terminal. Yeah, it's not this, it's this. Let me just stop this thing here because it will slow us down. This. Okay. So here, let us just run our front end. I think it's this one. Yeah, okay. So, substrate, node template, UI, and npm run. So we are basically firing our front end, and here, in order for us to start the chain that we've created, we need to run this. We have here a folder called target. We need to execute the release of our blockchain. It's basically runtime. There is no compile time here, so we are running target release. Okay. This and that. And this is firing our blockchain. We see here the node version. Here it's the other name, and there are also other specifications here. This is the height of this is the last block number, and here we are basically generating new blocks. So if we access our front end, I believe we will be able to see it. Let me just reload this. Okay, so we see here the block height is 1,400, which is here on the node. And we have here a default address, which I believe don't have any units in it. So we have here in Substrate for easier development, they provided us a pre-funded account called Alice. So we can import it here and send ourselves some units But in order for us to do that, we need to go again into the substrate node template and say, let me check what was the command. Okay, we are basically saying subkey. Just increase that. Subkey restore Alice. And this is giving us the seed and the accounts public key. So we're copying this.
So the seed is not on mnemonic, that's it?
It's a hex value. Here we can add it and say this is Alice. So here we now have added our Alice account, and if we check it here, Alice, we can see that it has lots of units of balance. And this is the address. So we can send ourselves some funds, Alice to default, and send 5,000 units. Let me just open here so we can see. Now we see that the balance is updated here. The transaction has passed. We set our block time to 5 seconds, so that's why we waited a bit before we receive it. So if we check here the default account, it has 5,000 units. Here I've updated the front end, but I'm gonna walk you through briefly to see what's in there. We have here, oops. Okay. And here on the node template, I need to be in the front end. Okay. So we have here in the front end a basic Vue.js app which has some server logic in it, and we have here some imports or some logic that are basically JS representations of the Parachain boilerplate. And we have here some sort of constructor where we are defining our player. This is a new point to our player, and this is the thing, the HTML that is being rendered on our screen. So this here is basically what we see here on this screen. And the whole thing, the thing that I've changed is only this. Here, from the divider downwards, I basically copy pasted here some logic from the containers above, and I've changed only this to show the player balance. Here is if the player is ready, which is if the account is loaded. And here I'm defining for the transaction that will be sent, that will going to be sent, which is the color and which is the sender. So which is the call. Sorry. This is we are defining the function that we're going to be calling to our Parachain. And down here we have the pod balance, which is basically reading the balance from the pod. That's it. So basic Vue.js with some variables defined here and imported from the boilerplate. When we run this CLI command substrate UI-view, basically gives you the whole structure of the project and you can poke around. So here we have the pod balance to be 1000 units initial. I've changed it, it was 0, but yeah. So here we are saying we want the default address to play the game. Just hit play and it lost. We can play again, send another transaction, and
Why?
live again.
Why there's 1 unit that is missing?
This is the transaction fee for our pod, which was defined closed, I believe. In the set payment logic, there were 2 lines of code. One is for transferring the amount to the pod, and another one for decreasing the value of the
Okay.
sender's
Okay.
transaction. Yeah. So basically, this is it. The thing that I haven't showed you yet is yeah, we won. Okay, so
That's
if
a
we
dangerous game.
yeah, if we change something to our trace module here, to our parachain, we can update it here, basically selecting the runtime, which is somewhere Polkadot substrate no template runtime in this wasn't folder target. This is here the release, and this is the wasn't block that is created for our parachain. So this is the whole thing that represents our parachain, and it's only 1064 kilobytes, so it's pretty small. So if we want to change something or the logic, or basically add another function or something like this to our network, to our parachain, we can just upload it here. This is visual representation, but we can do it only with signing a transaction, and we can upgrade it here. I'm not sure if it's gonna work now. Yeah, it worked, but if we change something, it's visualized here, the new version of the WASM, and the new, if there are new features that we are